So I want you to give me your best estimate for solving this. Okay, so on this first one, we have 10 to what power would give us 1,000? Yeah, I make it look really easy. Pull it down towards the board. There you go. Okay, so it would be, if we did 2, now it's not gonna work. 3 would be it, right? So A would equal 3. Okay, it's how many zeros we got, right? All right, what about this one? 10 to what power would give us 1? 0. Okay, this one's a little tricky. People start struggling with this one. 10 to the 3 halves. You remember that whole like turn it into a radical? Okay, so let's think about that really quick. So take the square root of 10 cubes. So can we do that? No, right? The answer is no. So we would leave it like that, or we could leave it like that. I just work it. Okay, and then the last one, what would that be? What would be your estimate on that one? 10 to what power give us 500? Well, we know 10 to the second power gives us 100, right? And 10 to the third power gives us 1,000. So 10 to what power would be 500? Like 2.5-ish, right? Okay, so logs help us find that answer. Oh, okay. Can't forget the logs. No. All right, so analyze the table and discuss with someone what you think the table tells us. Notice that some values in the columns labeled log of base 10 of x are whole numbers, but most are decimals. Why do you think this is? Take like 2 minutes, turn to your neighbor, discuss what you see. Go. Great. What did you see? The bottom ones are all whole numbers. Okay, let's think that through. What's 10 to the first power? 10 to the second? 10 to the third? Okay, we see the pattern. Okay, so log of base 10, if we have a whole number, we're gonna have something of a power of 10, right? Yeah. Okay. So let's focus on when the output is a whole number. So just like what we said, we got log of base 10 of 10, that's going to equal 1. Log of base 10 of 100 equals 2. Log of base 10 of 1,000 equals 3. Log of base 10 of 10,000 equals 4. What connections do you see? Okay, so what she's saying is that 10 to the first power equals 10. She's saying 10 to the second power would equal 100. That's exactly what she said. I know it. Yeah. Okay. So take a moment. I would write down the log version, and then I would write down the exponential version. So the hardest part is people are terrible at reading logs. They always say some weird stuff. So reading this equation, we get log of base 10 of 10 equals 1. Okay, so basically what this is saying is what exponent of 10 is needed to get to 10. Okay, I know that's kind of weird. So looking at the next one, I have log of base 10 of 100 equals 2. Log of base 10 of 100 equals 2. What exponent of 10 is needed to get to 100? That would be 2. Okay, so I would take a moment, kind of write down the important parts from this. Please don't read these things crazy. So recall that log of 1,000 equals 3. Really quick, mathematicians are super lazy. So if there is no number right here, this is assumed as log of base 10. Okay, same.
So is it always log of base 10 unless that?
Yes. Okay. Now log of base 10 of 1,000 equals 3. We already talked about that. So this is the same thing as what exponent of 10 is needed to get to 1,000. That's 3. So now we want to try it with a different base 10. Or I'm sorry, different base. So 5 to what power would give me 125? Okay, so 5 to the second is 25, And then 25 times 5 would give me 125. That's 3. Yes. So 5 to the third power equals 125. So log of base 5 of 125 equals 3. And this is the same thing as saying what exponent of 5 is needed to get to 125, and that is 3. Like equations and that kind of stuff. This is b raised to the y equals x. Or if we want it in the log form, we say log of base b of x equals y. This was a conversation we had yesterday or Tuesday, where if we want to put this in log form, we're going to do the circle of life. Okay, that's this order. Okay, so here it is again. When you do the circle of life, this comes first, then the x, then the y. If you wanted to go from log to exponential, watch this, same concept. Start at your base, go to the outside, finish over here. So b raised to the y equals x. Same thing. Circle of life lets you go from exponential to log. What? Yeah, and then you have to solve? Yeah. Okay. So take a moment. I want you to take this last right here, this log of base 2 of 16 equals 4, and write it in exponential form. And then I want you to take this guy and write it in log form. Take a second, see if you can do it. So if I'm going to go from log to exponential, I'm going to start at 2, go to the outside, finish over here. So 2 raised to the 4th power equals 16. Wow. Good, good, good. Okay. So on the next one, if we go from exponential to log, we're going to write log, and that's going to be base 5 of 1 over 25 equals negative 2. Yeah. Y'all are so enthusiastic. So we have log of base 3 of 81 equals x. How do you read this equation in words?
Log of base 3, you just said log of base 3 of 81 equals x.
Great. How do you read it in exponential form? Okay, good. Now, how can we write it in log from as an exponential? We already talked about the circle of life. Okay, and then what is x going to actually be? So 3 to what power would give us 81? 4. Okay. All right. Which form is easier to solve? Here's the deal. Ready? I'm trying to drop some knowledge. Okay. You can literally take this and go into Desmos and type that junk in. So what? Okay. Because when you ask me how to do it on the test, I'm going to say, I don't know. Okay. Because I'm just going to be stubborn like that. Okay. So if you go into the keyboard and you go to function, you scroll down and you look for log of base A, which is right here on the left-hand side. Okay. Okay, so Jared just dropped some knowledge. Okay, ready? LOG, hit the shift key and then hit minus. Type stuff. Okay, so if you do that, look at what it does. We love math, it's fun. Okay. Okay. I love Desmos. I don't like math. All right, cool. So now, if you need to evaluate a log with base 10, you use the log button. All right. Y'all doing too much. Remember that if you don't see a base next to the log, it's base 10. Okay, so for instance, you're going to do these 3. Where this one doesn't have a 10 right here, remember, we assume it's 10. Okay, cool, because mathematicians are trifling. Okay, so take a moment, please into your calculator, use Desmos, and then write them down. Move on. Okay, so let's talk about this next. What'd you get? Okay, and then what's the next one? Okay, what about the next one? 1 point. Okay, all right. Now let's have this conversation, because if one more person asks me if this is I in, I'm going to fight somebody. Log of base E, we talked about this the other day. Log of base E is the same thing as saying L in. Okay, L in. Yes, ma'am. L in. Okay, so what you're gonna do is type these three things in. Okay, when you type E, you literally type the letter E. Take a second, type it in. I'm not even gonna pause. Okay, so what you get for log of, I'm sorry, natural log of 2. I'm hearing like 7 million numbers. Do it again.
0.6931.
0.6931. Okay, cool. Log of E, fantastic. Log of 3, 1.89, blah, 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 blah. Okay. 1.09 on that one. The stuff you're gonna use on your SAT, ready? Yeah, it's happening. So back in the day, before we were able to use Desmos, we had to use our graphing calculators. Graphing calculators, you could not change, you couldn't put the base as anything other than 10. So they came up with a change of base formula. Okay, so this is back when I was in high school. We didn't have Desmos. We had to do this instead. So what you're gonna do, okay, first of all, what you're gonna do is you're going to take whatever the equation is, okay, and you'll do log of y divided by log of b. So it's basically like log of the bigger number divided by the little base. So I want you to take a moment and write log of base 3 of 45 in the log change of base form. Okay, so that would look like this: log of 45 divided by log of 3. And then you would plug that into your calculator and then you would get your answer. Can you try taking B and C and writing them in the change of base form? Okay, so this is gonna give me log of 0.5 divided by log of 5. Fantastic. The next one's gonna be log of 392 divided by log of 15. Now, unfortunately, you now have Desmos in the world, but on your SAT, you don't have access to using Desmos. So on the SAT, okay, you cannot use Desmos. You have to use a TI-84 blah, blah, blah calculator. Okay, so that's why you have to know this stuff. Yes. Okay, good luck. All right, so if I rewrite this in log form, watch what happens. I do 10 to the D equals 500. So this is going to be log of base 10 of 500 equals D. Now, can you plug that into your calculator and get a number? Yeah. So what is that going to be? 2.69. Take your word for it. Yeah. So if I put this into exponential form, it's going to give me 10 to the 4th equals A, which means that's going to give me 2, 3, 4, 10,000. If I plug this into Desmos, that's going to give me B equals, somebody help me out on that. 1 point what? You said LN of 15? Jason, I'm taking your answer to the curb. So sorry. Okay, on the next one, if I put this into log form, this is going to give me log of base E of 30 equals C. Remember, we can rewrite this log of base E as LN. And if I type this into my calculator, what am I going to get? Okay. Yep. Okay. I'm going to put this into log form. It's going to be log of base 5 of 37 equals D. I'm going to take this and I'm going to plug it into Desmos, and that's going to give me, wow. Wow. Future. 2 point what? Okay. Yep. The